CloudDB, shaping your new normal.
Little used features in DataPump. My name is Roy Swonger, Vice President for Database Upgrade, Migration, and Utilities and Patching at Oracle. And this talk was also heavily written by Bill Beauregard, our Senior Principal Product Manager for DataPump and Utilities as well. So sometimes when we deliver this, he will participate as well. But here's the list of topics that I'm going to cover. And this is a lot to cover in 45 minutes, so I will dive right into it. And this will be all technical, no marketing. One of the great things about DataPump is it's free, so I don't have to sell it to you, which makes it better for all of us. So this is a deep dive, but we're going to start at the high level into how DataPump works and how it's different from our old export and import utilities. Because the old export and import utilities were what we would call a thick client. All of the processing for export and import happened on the client side. That's why you had client-side dump files. But it became fairly inefficient, and there was no parallelism or anything like that. So when we built DataPump, we built it with a thin client. EXPDP and IMPDP are really very thin clients. And most of the work gets done on the server through packages, PL/SQL packages on the server. Now, there's another way you can access DataPump, and that is through the APIs, the DBMS DataPump API and the DBMS Metadata API. We'll talk about those more in a bit. Now, what the clients do is they invoke DataPump on the server. So they're basically just validating some parameters, sending the command to be executed on the server. And when that happens, we create a shadow process on the server to log into the database and kind of run things, the control process. The clients themselves use the very same DataPump API that you can access using PL/SQL packages, which are listed in the packages and types documentation. So the very same procedures that you would invoke, say, from a C program with embedded SQL are what we are invoking from the clients. And the DBMS Metadata API is used to extract, manipulate, compare, and otherwise work on the metadata for objects in the database. Now, when I talk about metadata, this is an important concept for DataPump because we really make a distinction between the data in your database, the stuff that you put into your tables, partitions, and subpartitions, and the metadata, which is the information about those objects, like a table definition as opposed to the table contents, or a constraint, a trigger, a user, a role, a dependency. Those individual pieces of metadata are very important for the structure and function of your database. And we have this entire metadata API to extract, manipulate, compare, and otherwise work with that metadata. And when we do that, we refer to the metadata in terms of what we call an object path. You see three examples there because there are three sets of object paths that DataPump can use, and it will use one set based on whatever mode of DataPump you're using. If you're doing a table mode export where you're saying tables equals, emp and depth, for example, well, there's a much smaller set of metadata that can be associated with a table compared to, say, a schema. Because for a schema, you would have things like the user would be part of the schema, and the things that can affect that user, such as roles and grants, for example, would be part of a schema export. And then at the database level, if you're doing a full export and import, you'd have even more different types of metadata that you can manipulate, such as audit policies, for example, are something that are only available at the database level. If you want to see all the different object paths that are available, and there are hundreds of them, you can query these views, the table export objects, schema export objects, and so on. And when you see that, what you've got is a hierarchical view of what each piece of metadata has. For example, if you look at the first element of that table export list, table statistics are a type of statistics that belong to a table. So there's an ownership and kind of a category hierarchy for each bit of metadata. You can have table statistics. You can have index statistics, for example, both of which could be associated with a table if you had an index on it. So when we look at the block diagram of data pump, this is what I meant when I said that most of data pump exists within the server. Those clients, the import and export clients, are outside the server, could be on a remote system, but everything else is going to live on the database server. And if you've used data pump, you've probably seen one effect of that, and that is the requirement that you use a directory object to access files with data pump. So we're not going to reach out over the network with data pump to access say something like your log files or write your dump files. And the reason for that has to do primarily with security, but also with performance. And the use of directory objects means that we can control access to those files. We can maintain security on those files using database security, not just operating system level security. And that's one of the requirements that was imposed on us when we were designing data pump. So on top of the DBMS data pump packages and the API there, we have access methods underneath that. Direct path, external tables, conventional path. I'll talk about those in a little bit, but those are how we actually read and write data to and from, or from and to our dump files. So that's a very high-level architectural view of data pump. Now let's get more into some specific topics, starting with parallelism. Now, in general, data pump takes great advantage of parallelism because one of the reasons we designed data pump was to take advantage of things that were new back in 10.1 and 10.2. And one of the things that was new was that's when a lot of multi-core CPUs came about, and we had a lot greater SMP, symmetric multiprocessing counts in our servers. So where original export and import were purely single-threaded, we wanted to take advantage of parallelism, even having multiple I/O controllers, for example, to get better performance. Well, we actually have two different kinds of parallelism in data pump. We have inter-partition parallelism, and that's probably the easiest to conceive of. If you have a partition table, we can take advantage of that by having one process load or unload each partition in the table. So if you have parallel 32 for data pump, we can have 32 parallel processes loading partitions or unloading partitions at a time. So when we do this, each worker process for data pump will be assigned one either subpartition or partition to load or unload, depending whether you're doing an import or export. But we also have intra-partition parallelism. That means that if you have a large partition or if you have an unpartitioned table, then we can invoke parallel query to break that large partition or very large object into multiple parts using the parallel query processes. So parallel query will automatically use parallelism for us if you have a larger partition, and that way we can load and unload data faster in those cases as well. So it even works on unpartitioned tables. Now, the one case where you can't use either of these is when you have basic file lobs in your database. The old style lobs, which been around for a very long time but have been superseded by secure files, that's our recommendation, use secure file lobs. Well, one reason we always recommend secure file lobs is that with the old style basic file lobs, we can't even unload data in parallel out of a table that has lobs in it. So even if you have 100 partitions in that table, we will still have just one and only one worker unloading a table if it has an old style lob column. If you use secure file lobs, then we can use full parallelism. So that's a great reason to migrate to secure file lobs. Okay, so going back to parallel operations. When you start a data pump job, we get that first process that I mentioned earlier. The shadow process becomes our control process for the job. And then you'll always have at least one worker process to do the loading and unloading of data and metadata. So that means that even if you say EXPDP parallel equals 1, you will have two processes, control process and one worker process, because that parallel argument that you use controls the number of active processes that will be loading or unloading data at any given time. There may be other processes associated with data pump, and I'll give you a very specific example in a little bit. So the control process is there to verify the parameters, make sure that everything is going to work properly, set up the control table, and then dole out work to each of the worker processes. So what do those worker processes do? Well, on export, we start with collecting metadata information about the job, whether it's table or schema or database. We have to first figure out, well, what is it that we have to export in this case? Because you might be specifying a schema or set of tables or including and excluding objects. So we collect everything that we need and we figure out all the dependent objects on it. So if you say table equals emp, good old Scott.emp, right? Well, we're not just going to get the table, but we'll get the dependent objects for it, the indexes, the constraints, the triggers, and so on. And then we write that metadata to the dump file in XML format. Now, XML format is very verbose. So we compress it by default so that your dump files don't get too large based on the amount of metadata that they have. And that compression has been around since 10.2, before the compression option even existed. So you don't have to pay for the compression option in order for us to compress the metadata. The compression option is required for compressing data. Well, once we have unloaded the metadata, then we unload the data. And we will do that using the data layer and the access methods that I'll talk about in a little bit. On the import side for parallelism, we do the reverse. We start by importing the metadata because, well, you have to import metadata before data. You can imagine that we have to, for example, create a table before we import the data for the table. And in order to create that table, we have to create the user that owns the table, and so on. So there's a lot of dependency ordering on import that we don't have to worry about on export. So we import the metadata up to a point where we can then start on the data, and then we start loading data into the database. Now, when we talk about loading data or unloading data, we think in terms of a unit of work. For metadata, the unit of work is that individual object path. It could be table statistics, it could be an index definition, it could be a user role. But for table data, the unit of work is the subpartition if you've got subpartitions, or partition, or tables if they're not partitioned. Now, one little tip here on the import side, or on the export side, if you are going to be changing your partitioning scheme, it's a good idea to export using data options equals group partition table data. And the reason for that is that that will export everything as if it was an unpartitioned table, so that when we go importing it, we can invoke parallel query to efficiently load data into multiple partitions at a time. Otherwise, we would end up using just one worker to load that table. Okay, so that's kind of the high level about parallelism. Now let's talk specifically about export. When we do a parallel export, we have multiple phases involved. And the reason for that is that we have to start by performing the estimate phase for the export. So the first thing we do is we estimate everything, and we get the metadata information. So each object path is a work unit. We collect the information about the metadata, and then we unload that metadata in parallel. For the data, however, what we do with the estimate phase is we're trying to figure out just how big is each item that you want to export, because it really makes it more efficient for us to export the biggest things first and then go through the smaller ones later once the bigger ones are done. Otherwise, we could end up with a case where we're using, say, 31 out of your 32 workers to export these little tiny tables, and then one worker on a really big one, and then that one worker gets stuck churning along at the end where it could have used parallel 32 up front. So the estimate phase is very important in figuring out what to do in which order to make it more efficient. Now, there's a dividing line between what happens before 12.2, so 12.102, 11.204, 10 anything, whatever. Those versions work very differently on export and import than 12.2 and later. And that's because we refine the parallelism starting in 12.2. So if you're exporting from 11.2, for example, we will start with that estimate phase, and it will default to estimate equal blocks in 11.2. And what that will do is it'll gather all the table data objects, figure out how big they are, and what order to export them in. Then we export the metadata serially with just one worker and export the data in parallel. But starting in 12.2, we do a lot more things in parallel. For example, while we're doing the export or the estimate phase, we start exporting metadata, and we're going to export the metadata itself in parallel. So that generally by the time the estimate phase is over, we can start, not only can we start exporting our data, but we've already exported most of the metadata at that point. So we figure out how much parallelism we're going to need for the metadata. We reserve workers for that, and then we go about the data and then adding more workers for data once metadata has exported. So this is an example of what I mean here. If you're doing an export from 12.102, and you said, in this case, parallel 16, if it's 12.102, you'd see one worker startup, and that's that startup took 2 seconds there, and then we would start estimating how much we would do for data, and then we would export all the metadata that we need to do, and then once we get to the point of doing table data, then we start up the other workers. So you see in this case, those other workers haven't even started up until 2 minutes into the job, where on 12.2 and later, we start all the workers right away, we start the estimate phase, we start exporting metadata, and then we get to the data very soon after that. It doesn't show on the screen. But that just shows how we continually try to get smarter about using parallelism and making sure that none of your resources that you've devoted to this job, in this case parallel workers, none of them are sitting idle when they don't need to be. So for parallel metadata export, your source database has to be 12.2 or higher. Starting in 12.2, we also changed how we do the estimation phase. Before 12.2, we would estimate by default saying estimate equal blocks. And on a really big database, that could be very expensive because that means scanning through, say, SegDollar and figuring out how big every single object is in that database based on the number of storage segments and the size of those segments. And in some cases, the estimate phase could actually take longer than unloading all the data. So starting in 12.2, we've moved to estimate equals statistics being the default. But that also means that having good statistics is very important for data pump performance. So with parallel metadata export, restart will still work, and database objects that have dependencies might be exported serially, but other ones are going to be exported in parallel. So how do you make this work as well as possible? One is to have really good statistics, especially dictionary statistics. That's very important for data pump because we're often accessing tab dollar, source dollar, user dollar, and so on. Second, fixed object statistics. And then third is just having good database statistics overall, because your table and index sizes will determine the order in which we're going to export and import those things. On import, it will really help if you can convert your lobs into secure files. Actually, if you can do it at any time, it's going to help your performance. We'll get parallelism, it scales better. Secure file lobs have been around now for something like 15 years. It's proven technology. You should really be using that. Now, when you export with parallelism, always use a wildcard for your dump file names. That allows us to create automatically parallel dump files so that we can write in parallel. If you say parallel equals 32, but you give us one dump file to write to, then you're still only going to get one worker active at any time because writers do block writers. So you'd have one worker writes out and 31 of them are waiting. So always use the wildcard. And again, starting in, I think it was 12.2, use %L to be able to have up to more than 2 billion dump files automatically created depending on your file size and so on. So you can control your dump file size using the file size parameter. So I mentioned that I'd give you a specific example of how many processes you could get with data pump. So this is just one example. Let's say you did an export and said parallel equals 6. And you might be thinking, well, that means I'll get 6 data pump processes created. Not quite, actually. So first of all, as I mentioned before, you'll have the control process. That's there for every data pump job. So you'll definitely have that control process there. And then you're going to have some number of parallel workers, but it might not be 6. So here's an example of why that might be. In this case, what we have is the first worker. So you've got your control process. You've got the first worker that's unloading the metadata. In this case, maybe we only needed one to do that serially, whatever. Then the second worker is going to actually invoke parallel query because it's got a somewhat large partition to export. So it is going to coordinate 2 parallel query processes. And then the third worker is unloading a smaller subpartition, so it can do that by itself. Then the fourth worker coordinates 2 more processes of parallel query. And now you have a total of 9 processes doing this work, even though you said parallel equals 6. So that's just one example of how this might work. Another thing that could happen, by the way, is if you said parallel equals 32, and you are only exporting, say, one table that has, say, 4 subpartitions, we're not going to create 32 processes just for fun. We're only going to create them if we need it. So you could have fewer processes, or you could have more processes than your parallel parameter. Okay, let's contrast this with parallel import. On import, we don't have to do an estimate phase because all the information we need is in the dump file about the object sizes and ordering. First, we'll load the metadata in parallel, starting with 12.2, and then we'll load the data. After we load the data, we build indexes simultaneously and other metadata that gets built after the data is loaded. So, for example, one reason we do the indexes after the data is if we built the indexes first, then you would have index maintenance every time we loaded a row into the table. It would really slow down the data load. We load package bodies in parallel, and as we mentioned, data is loaded in parallel. And again, that dividing line at 12.2 is very important when it comes to metadata import. And I hope, by the way, that no one is really being super active pre-12.2 now, because 11.204 is well into its market-driven support. 12.102 is going to go out of support next year. You should be going to 19C. But if, for whatever reason, you're still importing into 12.102 or 11.204, what we do is we have one worker per partition or subpartition. We will use parallel query, as you saw, if partitions are large enough. We'll load package bodies in parallel, but all of the other metadata is loaded serially. Now, if you want to load or build indexes in parallel, you could get the patch for the bug number you see there. Now, when you do that, what happens is normally pre-12.2, when we build an index, we would say create index, and as part of the create index statement, there's a parallel keyword that would tell parallel query to build the index using parallel query processes. Well, what we found is that in most cases, about 95 to 99% of all cases, it's actually better to build an index with create index parallel 1 and build multiple indexes at a time. So we switched to that in 12.2. You can get that 12.2 behavior with this patch in 12.102 or 11.204. Just be aware of how it works, because there is that case where the new behavior is actually not as good if you have a bunch of small indexes. Let's say you have 100 really small indexes and then 2 really, really big ones. Well, in that case, the old behavior actually works better, where you can build those indexes using parallel query, and the small ones don't really take up that much time. So let me give you an example of how parallel metadata import works. And remember, we've exported the metadata into the dump file in these XML documents. And each XML document contains a certain number of entries for that particular category of metadata, like so many users or types or indexes. So in this case, let's just say we have exported 161 user objects as part of our export. And in this case, for users, we put 80 create user statements in each XML document in the dump file. And we then assign one XML document to each worker. which means that workers 1 and 2 in this case will each load an XML document of create user statements that holds 80 users. And then worker 3 would have 1 left over. So 80 plus 80 plus 1, it's 161 users. And that's the parallelism that you would see on workers in this case. So even if you had parallel 32, once you got to users, we would only have 3 workers active. It's not perfect scaling, but it still can be pretty efficient. So this will work for conventional dump file jobs. Starting in 21, our import will, for transportable table spaces, will also do metadata in parallel. So here's a difference of how you'd see it in the log file. If you imported, in this case, eBusiness Suite database, which I'll show you in more detail in a second, and just look at the object grants there, over 27,000 object grants in this case. And 12.102, one worker would be assigned to import all those object grants one at a time. So it's doing create grant, a whole bunch of them, 27,586 times. In 12.201, what we do is we assign XML documents one at a time to the workers. And in this case, since we've said parallel equals 8, each worker will get one document at a time, and eventually we'll get through all of the grants. I don't know how many grants are in a document, but just say maybe it was another 80 or 100, whatever. But in the end, you can see that the grants get spread out very evenly across those 8 workers because there are a lot of grants here. And that's pretty efficient. We import those object grants 5 times faster with 8 workers than we do with 1. So that's reasonable scaling for parallelism. And here is the kind of global measurements that we did on our parallelism, comparing 11.204 without that patch to do indexes faster, and 12.102 also with parallel. But then you compare that to 12.2 or to 12.2 with even more parallelism. And look at indexes, for example. In 11.204, by default, the 53,000 indexes in eBusiness Suite database would take 110 minutes, almost 2 hours to import, whereas same database importing into 12.201 with the same command would actually take just 4.5 minutes for those same 53,000 indexes. So certain types of metadata really benefit from this, but others don't. Like types, for example, you see that types, it says they are handled by a single worker. The reason for that is very simple: type inheritance. You can have multiple versions of a type, and we absolutely have to import those in the right order, so that dependency ordering forces us to use one worker for importing types. The same is true for procedural actions and so on. Okay, so that's hopefully everything you need to know about parallelism. I mentioned earlier that DataPump has different access methods underneath the DBMS DataPump API. We can move data in different ways, and we do this for different reasons. The 3 most common approaches we use are the Direct Path API, which moves chunks of data in and out of the database in a format that's similar to but not identical to a database block. Then there's external tables. The external table API allows you to access files, non-database files on disk, using SQL to access them. And then insert as select over a DB link if you're using a network mode import. Now, the other method that's available is what we call conventional path. And that is used in cases where we cannot use direct path or external tables to move data. And I'll talk about why that could happen in a second. In general, you should not have to worry about the access method. DataPump will just do the right thing based on the structure and contents of a table. So what do I mean by that, by structure and contents? Well, external tables has the advantage of using parallelism. So if we're moving a table that is partitioned, then it will automatically, when we're using external tables, it will automatically use parallelism over those partitions and can be very efficient, whereas direct path is very fast on a single work item, but it is serial. So think about it as direct path is the fastest way to move one thing, but external tables is the fastest way to move a lot of things. So look at it this way. It's like the comparing the speed limit on a highway with the number of lanes on a highway. If you really want to go fast and you got a sports car, go on the fastest, go on the Autobahn. But if you've got 100,000 people to move, well, you might want to have an 8-lane highway. So we will choose the optimal approach based on the structure, but also the restrictions that each of these methods has. External tables, for example, does not move long or long raw data. That's a design relic because when it was designed, we had already deprecated long and long raw. And even though those data types are still supported, external tables does not support them. Direct path, on the other hand, can't be used to load into a pre-existing table. So if you're doing an IMPDP and you say table exists action equals append because you've already got the tables created, well, you won't see direct path being used. It's always going to be external tables. But, well, what happens if you've got a table that has long or long raw data and it already exists? Can't use external tables, can't use direct path. What do? That's when we default to conventional path, which is the slowest but universally usable method to load and unload data. So what if you choose the wrong method? What if you had a table with a long raw column in it and you told us explicitly access method equals external table? We will come back and say, nope, can't do it. We'll give you a very explicit error message saying that we cannot move that table using the external tables method. So you can at least know that if you do decide to try to specify one access method or another, we will still make sure that it's okay before we try to do that. Okay, changing gears now. The data pump control table. I mentioned this is used to do a lot of things. It validates parameters, sets up the control process validates parameters, but it also builds this control table. And what this control table does is it is very important to the job because it catalogs everything that is going to happen or has happened in the data pump job. It's a database table where when we were collecting all that information about metadata and table objects, we write it to this control table, and then using this, the control process can say, well, what's the next thing that I have to do? And it can parcel that work out to a worker, and the workers can keep track of what they have done, when they've completed, and so on. On successful completion of a data pump job, we get rid of this table. If you want to keep it around for various reasons, such as diagnosing performance, or maybe support will ask for the control table if they want to see what the characteristics of the job were because you have some sort of issue here, then you can specify keep_master equals yes on the command line, and we will keep that table around in the database, and you can export it and upload it with an SR or something like that. So the benefits to having a table that controls all of the data pump activity, well, one is that we can query it. We can always tell exactly what's happening in the job. Two is that we can use it to subset the job. So if you do a full database export, and then you want to import only a couple of tables out of your massive set of dump files, well, that control table will tell us exactly where, in which files, and what offsets the blocks for that table are stored. So it makes it much faster for us to import, for example, a subset of a job. And it also is the key to having data pump jobs be restartable. So the reason for that we'll get to in a second. Just kind of a little tangential topic. We often get asked about these marker objects that you might see in a log file. And for example, you might see it exporting statistics marker object. And that may take a significant amount of time in a database, especially a complex database with a lot of indexes and subpartitions and partitions and so on. So people will ask us, well, what do I need this marker for? I don't use a marker object. And that's true. You don't use marker objects. What a marker object is for data pump, it's a place where data pump is actually kind of stepping outside of data pump to call another part of the database to do work. And in the case of stats, for example, when we export statistics, we're actually making a call to the DBMS stats package to export statistics. So that's a marker in the dump file that says, at this point, we're calling dbms-stats.export statistics. That's doing the work. And then when it comes back, we say that it's been done. So you can't exclude the marker itself. If you don't want that amount of time taken to export statistics, you actually exclude the statistics, not the marker. Okay, let's talk then about export restart. So an export job can be restarted as long as we have finished the estimate phase. In other words, once we have figured out everything that is part of the job, that's the point at which a job becomes restartable. That means we've created the control table, which says catalogs every bit of data and metadata that's going to be exported as part of the job. And for each one of those, there's what we call a type completion row in that table. So if you look at the example below, very simplified example, we have two completely different types of objects where it's saying, well, we started exporting this table space definition at 904.01, and it finished at 905.23. So we finished the table space object type. And then we start with users, but for whatever reason, this job did not complete and it stopped in the middle of trying to export users. So now if we restart the job, we know that we can start after table spaces and restart users. So this gives us a way to restart where we left off in the job. The same is true on import, except on import it can be even more granular. So because on export, remember, we're writing metadata to these XML files, and we are writing out chunks of metadata at a time. Well, on import, we don't really do that as much because we have to know whether we've imported an individual object, like an individual table. If we've already imported it, we can't recreate it again. So what we do is there's a row for every individual object in the import job, and each one of those has a processing status of whether it's in the current set of objects being worked on or not, and then a processing state, which says, has it been written to the database? Is it underway? Has it been retrieved, but maybe not written yet? So in this case, if I restarted this job, I could say, okay, the things we were working on when this job stopped, for whatever reason, maybe you were out of disk space or the server crashed, or maybe you just paused it if you wanted to. We would know what things we were working on at the time, and in this case, we'd know that scott.foo has already been written, so we don't have to do that, and we would start again on scott.bar and the two indexes. So for including and exclude, you might have seen that in a couple of these examples here. This is something new in 21C where you can include and exclude objects in the same job. Now, this is a long requested new feature for Data Pump. Originally, export import, the old utilities, you could say constraints equals yes or no, triggers yes or no, for example. You could say constraints yes, triggers no, if you wanted to. Well, with Data Pump, our include and exclude is much more powerful. You can get very hyper-specific about what you're including and excluding, but until 21, you couldn't do an exclude and an include in the same job. We finally put that in 21. And the way it will work is that we start with the includes. So when you include in the Data Pump job, you say, the only things I want are the things I've included. And then when you exclude in the Data Pump job, what you were saying before 21 is, I want everything except for what I'm excluding. Well, if we do them both in the same job, we process the include first, followed by the exclude. It turns out that's kind of the only way to logically do it. So if you said include equals table, for example, you don't just get tables. Remember, you get the dependent objects. So not just the table definition, but things like the grants, the constraints, the triggers, the statistics, all of that stuff associated with the table. But if you also now say exclude equals statistics, then those two statistics entries will not be part of your export, or in this case, your import. So it allows you to get more fine control over what you're importing and excluding. Before this, what you would have had to do was do the include on your export and then do the exclude on your import. You could kind of achieve the same effect, but it would be by actually exporting more than you wanted. So this is an improvement. So I mentioned you could do things like pause a job yourself, and that's one of the interactive commands that we have available. Now, the interactive command line for data pump is invoked when you hit Control-C when a job is running. That allows you to interact with the job via a command line interface that has a few commands, like getting the status, which will show you what every individual parallel process is working on at any given time. You can change the parallelism of a job on the fly. It'll take effect immediately after the workers are done whatever they're working on right now. You can add tracing to a job, and I'll talk about tracing briefly in a second. And by the way, we'll talk more about the interactive command line in the little used features talk that we are giving in a couple of weeks. If you want to troubleshoot your data pump jobs, first thing you want to do is make sure you have good diagnostics on your command line. Metrics equals yes, log time equal all will give you a timestamp on every line of your log file and details about the parallelism and how long it takes each individual type of object or each individual data work item to be moved in or out of the database. So you see the difference having metrics equals Y or not in this case. All the information that you get in terms of the timestamps, the worker number, W-1 means that's worker number 1, how many rows, not just how many rows, but how long did it take to move the data. So in addition to doing that, you can have extra troubleshooting using the trace parameter. And this is the last topic we're going to talk about today. So the trace parameter, it does require a privileged user because trace files can get very large, and we don't want people basically doing a denial of service by just generating massive trace files and filling up disks. So you have the DBA role or the EXP or IMP full database role, both of those very high privilege there. And you can set the trace parameter on the command line to tell us what you want to trace. Now, here is most of the trace flags that you could set. There are actually some more that are a little more arcane that we're not putting here. And I'll tell you what the normal tracing we would request is. Now, again, tracing is not something you should do for fun. Tracing has performance overhead associated with it because it generates a lot of data for us to go through when we're diagnosing issues. But if you're asked to perform tracing by, say, an SR support engineer who's working on an SR, this is what they're asking you about. So tracing, we have all these different levels of tracing depending on whether we're dealing with the worker or the control process, the metadata area, or is a job a transportable job or not? Is it in the procedural actions? There are lots of things we could trace, and you could trace everything using, as you see there, the bitmask 1FFF0300, but that would generate huge amounts of data, so you should not do that by default. What we would normally ask for is if we have an issue with the control process, it would be 80300, the worker would be 400300, or or that combination of the two for 80300. That would be like, let's say you're running data pump, you get an Aura 600, that's probably what they would ask you for to help diagnose what the call stack was, what each worker was doing at the time. And if you did that, you would get trace files in your diagnostic destination trace subdirectory, and the trace files have _DM for the control process or _DW for each worker. So you could have multiple worker traces if you're using parallelism. Mentioned that you can trace all components if you want to. Do not ever do that unless support tells you to. And beyond that, I'll just mention that you could also implement tracing. If you didn't do it on the command line, you could do things like attach to a running job and specify the trace file as part of the attach command, or from within the interactive command line, you can set tracing and it will take effect with the next work item for a worker or for the control process. So that's really useful if you've got a job that's running really slow, or you think it's hung and maybe it turns out it's not hung, but the workers are just slowly moving along. Implement tracing and we'll see what's going on there. And you can set tracing in your init.ora. Wouldn't generally recommend this because this means you'll set tracing for every single user on the system. Normally not something you would want to do. And you can do SQL tracing as well. Again, very voluminous, a lot of overhead involved with SQL tracing. Only do that if support asks you to. So, I know I went a little over time due to the issues with the microphone at the beginning. Sorry about that. I hope this was useful to you. Now, this is just a part of a deep dive here. We've also got this whole set of webinars around upgrade and migration. We've got 11 of them so far, and you can see where to get them at Mike Dietrich or Daniel Overby Hansen's blogs. They're all free on demand. They all run somewhere between 90 minutes and 2 hours on specific topics that you see listed here. And coming up in March, we actually just delayed it. It's going to be March. We're going to do a deep dive into Data Pump. It's going to be 2 hours on Data Pump. I will tell you that you can get those 2 hours basically by seeing the 3 talks that we're going to do at the APAC Groundbreakers tour here. So that webinar that we do in March is essentially going to be the same information, maybe with some updates, but the 3 45-minute talks here, as you can imagine, add up to about a 2-hour talk in March. But a lot of information about upgrading and migrating databases there. We also have a YouTube channel where we break that information down into bite-sized chunks of 3 to 8 minutes. And with that, I'd say shishini, arigatou gozaimasu. Thank you very much for listening, and we can look at questions now.
Thank you so much, Roy. Amazing session as always. If anyone has any questions, please feel free to post the questions on the chat window of the app in the lower right side of the page. Of course, Roy, the invitation is always open to do seminars for the ANZ, Australia, New Zealand, also to Chile and Latin America. Hopefully the things improve and we can start having face-to-face events and we can have you guys around again. And if not, we will be more than honored to organize anything to you guys for Latin America and also to the Australia, New Zealand, and Asia Pacific too. Some webinars with you and your team that everybody always love to hear from you guys.
Yeah, when we are like everybody else, we're so looking forward to the time when we can see people in person, travel. I've been to Australia 4 times, New Zealand once. Of course, I've done the Latin America tour. And then actually, just before COVID hit, I had a trip to Korea where we were going to be meeting with folks there that was unfortunately not able to. I'm not seeing any questions yet, but if anyone has any, by all means, type them in. I know it can be a little daunting to do that, but happy to answer anything you might want to ask.
Yeah. Sounds good. Looks like the people is a little bit shy today. They are not posting any questions. Italo from Chile is saying, thanks, Roy. I don't have any questions. I will see the pages that you show to go deeply on this. Thank you again. And also, as part of the APAC virtual tour, the platform videos will start to be uploaded from tomorrow. And basically, all these sessions that the people is registered to assist, you need to register to the sessions. Then you go to your attendee tab, you're going to see your personal agenda, and there you're going to see the links to the live sessions that did not happen yet, but the ones that already passed, and you register, you're going to see the replay or playback option to watch the videos once again or many times you wish. And the playbacks will be available until the 30th of December for all sessions. And saying that, you can see in the screen that Roy is showing all the information again. And please feel free to contact Roy by Twitter or his email. And if you have any questions watching also the replays or playbacks of the sessions, once again. Saying that, thank you so much, Roy. Amazing session. Thank you for taking the time. I know for you it's Sunday. Apologies for that. And please take care and be safe on these pandemic times, everyone.
Okay, thank you all.
Cheers. Have a wonderful day, a wonderful evening for you, Roy, and a wonderful day to everyone in Asia Pacific.
Thank you as well. Thanks.
Bye-bye.
CloudDB, shaping your new normal.